Hello everyone, welcome to another concept clearing video of Newton gates. In this video, we will discuss about the second chapter in mathematics CBSE, that is polynomial. In this video, we will briefly go through the following topics. What are polynomials, its definition, degree, the types, and what are the zeros of the polynomial. Next, we will move on to the geometrical interpretation of zeros of a polynomial. That is, in graphical representation or pictorially, what does zeros of a particular polynomial looks like. Then, the most important of the whole chapter, that is the relationship between the zeros and coefficients of the polynomial. And last, we'll end the topic with division algorithm of a polynomial. Polynomial. The word polynomial comes from the word poly and nomial. Poly means many and nomial in this case means term. So combining both, polynomials means many terms. Okay. Now the polynomials are made up of terms that are added, subtracted or multiplied. Next is degree of a polynomial. Now what exactly is degree of a polynomial? Let Px be a polynomial in X. Okay. Now this Px refers to polynomial in X. If we write Py, it means polynomial in Y. The variable in the bracket is actually the variable which we use in the polynomial. So Px, let Px be X plus 1. Okay. Now here the power of X is 1 and here if I break it, it will become 1 into X to the power 0. I can represent it in this form also. So the power of X in the first term is 1, whereas in the second term it is 0. The highest power in both this comparing, we get it is 1. So the degree of polynomial becomes 1. Next, here I have taken another example, 3x square plus 2x minus 8. Okay. Here, the highest power of x is 2. So, degree is 2. Now, please note that we have to make sure that whether or not they are in order or not. Sometimes a polynomial can be given like this. For example, I can write a polynomial like this. 3x square minus 4x cube plus 1 equal to 0. Now, as you can see, the power of x are not given in order. Okay. So, in this case, the highest order that the x is having is 3. So, the degree of polynomial also will be 3. So, please take a note that the degree of a polynomial does not depend upon which is coming first or which is coming second. It only depends upon the power of x. That is how much the power x is raising and what is its highest power. And that will be the degree of that particular polynomial. Now, on the basis of the degrees, polynomials can be divided into 5 parts or 5 types. The first is constant terms, that is all the numbers like minus 1 by 2, 1 or 0, minus 3 by 4, 2 by 3, all these are constant. These also are polynomials, but all of them are just constants, and as I had taken the previous example, x square plus 1, so I had written 1 into x to the power 0, right? So, if I just write 1, I can represent it as 1 into x to the power 0, right? So, as you can see, the power, the highest power that x is being raised here is 0. So, that is, it's a constant. So, the types of polynomial with degree 0 is called constant. The next is degree 1, that is a linear equation, which we have done in previous classes. So all the polynomials of this form, where we have only one x and with power 1, is called linear equation or linear polynomial. Then comes quadratic. Now quadratic is with power 2. Any polynomial with the highest degree 2 is called quadratic equation or quadratic polynomial. Here an example is given. The next is cubic. Cubic, as the word sounds, the degree of this polynomial is 3. And last we have biquadratic, which is 4. Now obviously there are higher powers also, but as of now we will be dealing with this type, especially quadratic, cubic and linear. Okay, so let's move on. Well, when the polynomial, suppose here I am taking x square plus 4x plus 4. Okay, here I am taking a polynomial. Okay, now definitely this is of degree 2, but here we are not bothered about that. We want to discuss what is the value of a polynomial and what exactly is the zero of a polynomial. Okay, so let me take two values here. One, I am taking x equal to 1, another I am taking x equal to minus 2. So let us put both these values in this polynomial. This I am naming it as px. Okay, so when we put 1, we get 1 plus 4 plus 4, that is 9. So this is the value of the polynomial. But when we put x equal to minus 2, what do we get? We get 4 minus 8 plus 4, that is equal to 0. Yes, this is still the value of the polynomial at x equal to minus 2, but this has a special name also. Okay, that is x equal to minus 2 becomes the 0 of the polynomial. Why? Because when we put x equal to minus 2 in this equation, the value of this equation becomes 0 and hence the name 0 of a polynomial. Okay, this is the basic difference between value of a polynomial and the 0 of a polynomial. Value of a polynomial means whatever value of x you take, the particular value which you get, like at x equal to 1, we got a value 9. This is the value of a polynomial. But when we put x equal to minus 2, we got 0. So x equal to minus 2 becomes the zeros of a polynomial. Now, for any kind of equation or for any kind of polynomial, the degree n gives the number of the zeros. That means a quadratic equation will have 2 zeros maximum. Okay, a cubic polynomial will have 3 zeros. Now it might be that some will be repeated, some might be common, or maybe all of them are distinct, but maximum n number of zeros is possible for a polynomial with degree n. Now here, by meaning of maximum n number of zeros means we will get n maximum n real zeros. Okay, there is a concept of imaginary or complex which we will learn in later classes. Okay, but as of now, let us understand what are maximum n number of zeros in our next slide. The geometrical meaning of the zeros of a polynomial. So, zeros of a polynomial in graphical representation looks like this. Here I have taken the graph of a straight line or a linear polynomial, that is with degree 1. Okay, so this is the graphical representation. Now here, as you can see, the line or the graph is intersecting x-axis at one point. So ax plus b, let's say this is the equation or the value of this polynomial for which the diagram has been drawn. Now the theory said that the equation with the power, polynomials with n as the degree will have maximum n number of zeros. Okay. In graphical representation also, we say that the number of times the polynomial is intersecting the x-axis is equal to the number of zeros. So here, as you can see that the graph is intersected at one y-axis and one point of x-axis. So, since it has intersected x-axis once, so it will have 1, 0. So, it relates with the theorem that we had learned previously. Now, let us come to the graph of a quadratic polynomial, which is a very important topic for the examination, especially for MCQs and the short type of answers. This kind of graph is given and it's favored by CBSE, as many of us confuses that how many zeros will be there by seeing the graph. Well, always remember that whatever the graph is, we just consider the number of times it is intersecting the x-axis. We do not see how many times it has intersected y-axis or any other. But yes, do remember that the origin is also the part of your x-axis. 0, 0 is a part of x-axis as well. So if a graph is moving like this, okay, it will have 1, 2, 3 zeros. Okay, sometimes students miss this point as they think that since it is passing through the origin, it is not the x-axis. But please do not make this mistake. Okay, 0, 0 is also a part of the x-axis, so we consider that point also. Now, in this case, we have taken a graph where a is less than 0. Now, what exactly is a? Now, if you remember, we had taken the general form of a quadratic equation as ax square plus bx plus c equal to 0. Or this is the polynomial representation of a quadratic polynomial. Now, here the coefficient of x square, if it is greater than 0, the graph of a quadratic polynomial will look like this. And if it is less than 0, that is a negative number, the graph will look like this. Now, by seeing the graph, you can see that it is intersecting at exactly 2 points. So, graphically also we can say that yes, this graph is having, or this polynomial is having 2 zeros, or sometimes it is also said as 2 roots. That is, this equation has 2 roots. Here I have taken another case and I have shown that here, as you can see, that the graph is intersecting at one single point, right? But it does not mean that the graph is having only 1 zero. It just means that it is having a repeated root. Now, what is repeated root or repeated zeros or repeated roots? Repeated means sometimes, like for example, x square plus 4x plus 4 equal to 0 has the roots of the zeros minus 2 and minus 2. So, here it means that yes, the graph or the polynomial still has 2 zeros, but not all of them are distinct. Okay, here both the zeros are your common. Okay, they are the same thing. So that is why in the graph it is intersecting at the same point, but it does not mean that the graph is having only 1 zero. It just means that the graph is having 2 zeros, but both of them are the same. Here we have taken the example of fx equal to x square. Now x square becomes 0 at 0, 0. Both the time if we place x equal to 0, we get the equation, and hence it is crossing the line at just x equal to 0. So again, here I have taken another case, and here I have shown you that the graph is neither intersecting any point of x-axis, or even if it is touching, it is touching at y-axis. So here we cannot say that the graph is having 1 0. See, entirely, yes, it is still intersecting at one point of y-axis, but we still will say that there is no 0 because there is nowhere it is intersecting x-axis. Remember, I am repeating it again. Always remember this, that the number of times, or if the graph is intersecting the x-axis, only then we will say that the 0 is possible or the 0 is present. Hence, we conclude that a quadratic polynomial, that is any polynomial with degree 2, can have either 2 zeros, 1 zero or no zero. Okay, that is, we can say that it can have at max 2 zeros. Now, in this chapter or in this class, we only deal with the real number or real roots or the real zeros. In higher classes, you will read about imaginary roots or imaginary zeros also. Then we will understand the full concept. But as of now, we just need to know that if the graph is showing no zeros, it means that it does not have any real zeros. Next, the most important topic in this chapter is the relationship between the coefficient and the zeros of a polynomial. Here I have taken the 3 types of polynomial which is there in your syllabus, especially the one with quadratic is very important, and the next is cubic. Well, here ax square plus bx plus c. Okay, if we take this ax square plus bx plus c. Now what is coefficient and what is zeros? Well, as discussed before, zeros are the values of x for which this whole equation will give you the value 0. And coefficient is the numerical value which is present before the x square, present before the x and the constant term. Okay, so there is a relationship between the zeros of a polynomial and the coefficients of a polynomial. Now what is this? Suppose this particular quadratic equation has zeros alpha and beta. Okay, that is for alpha and beta values of x, this total equation will become 0. Now, then it becomes that the zeros of the polynomial. Now, sum of these zeros is equal to minus b by a, that is the coefficient b and the coefficient a, whereas the product of the zeros is c by a. Next is the product of the zeros. The product of the zeros is alpha beta and that is equal to c by a. Okay, now remember this. Sometimes what happens in the equation or the polynomial is might be given as cx square plus bx plus a equal to 0. Right? Remember, if I have to be more specific, sum of the zeros means minus of constant of x or coefficient of x square. That is this constant and this x square. It does not depend upon a, b, c. It depends upon the coefficient of x square, it depends upon the coefficient of x and it depends upon the constant term. Okay, so it's better if we understand this rather than this. It is easier to memorize this, but please understand that b by a or c by a is not important. What important is the constant of x and the coefficient of x square. We are more bothered about the coefficient of x square than seeing a, b and c in order. For the cubic term, we have ax cube plus bx plus c, and here also you have sum of the zeros. It is coefficient of x square divided by coefficient of x cube. Product of the sum of zeros taken 2 at a time is c by a, and product of zeros is minus c by a. Now we will be discussing some examples. The first sum is from NCERT itself. It is the number, find the zeros of the quadratic polynomial t square minus 15 and verify the relationship between zeros of the coefficient. Now, by finding the zeros of the quadratic polynomial, yes, we can use the factorization method. As you can see, t square minus 15 is t plus root 15 and t minus root 15. So that means in other words, t equal to root 15 and t equal to minus root 15 are the zeros of the polynomial. Right? Now, sum of zeros is how much? sum of zeros. See, here I am not applying the formula of coefficients here. Here I am just applying this and this, that is root 15 minus root 15 equal to 0. Okay, and the product will be root 15 into minus of root 15. Please be very careful about this sign. It is minus 15. Okay, this entirely is done upon finding the roots using the factorization method. I have still not applied the coefficient or the relation which we have studied. Now we will get to that. So here, as you can see, sum of the zeros is 0, and here by using the coefficient of t divided by coefficient of t square, so t square minus 15 equal to 0. What is the coefficient of t? Well, we have no term with t, so it is 0. And what is the coefficient of t square? It is 1. So minus 0 by 1 is 0. Well, it was true. When we added, it also becomes 0. And same thing for the product. Next, let us move to another example. Here I have taken x square plus 7x plus 10. Again, by using the midterm factorization, we have found for which values of x does this whole equation become 0. That is minus 2 and minus 5. So let us see. Minus 2 minus 5 is equal to minus 7. And minus 2 into minus 5 is equal to 10. So the product of the zeros is 10 and the sum of the zeros is minus 7. Let's see if we get the same thing using the formula. Now, sum of the zeros is the coefficient minus of coefficient of t or coefficient of x divided by coefficient of x square. Now, seeing this equation, the coefficient of x is minus 7 divided by 1 equal to minus 7. And the product is the constant term by the coefficient of x square, that is 10. So, both the variation or both the verification is true, and hence we know that the formula or the relation between the coefficient is true. Here I have taken another example. 4 and 1 are the zeros, okay, and with that we have to make the equation. The equation is not given, we are just given the zeros. So alpha plus beta is equal to 4 and alpha beta is equal to 1. Now a general equation is of this form: alpha plus beta x plus alpha beta equal to 0. Now if we put the value in this equation, we get x square minus 4x plus 1 equal to 0. Moving on, this is a very important example. Here I have taken k square minus 14x square minus 2x minus 12 as the polynomial, and we have said that the sum of the polynomial, that is alpha plus beta, is 1, right? And we have to find the product and also the value of k. Now the product of the zeros is alpha beta, and that is minus 12 by k square minus 14. So here we have written, okay. Now minus b by a. What is b? So we have put here minus b. K square by 14 is equal to 1. Now solving it, we get k plus minus 4. Now it is important to see whether or not the k value satisfies this equation or not. Now here most of the time it satisfies. It's still better to see by putting the value here whether or not we are getting the value 0 or not. Another example is, find the condition where if this is the polynomial, one root is the reciprocal of the other. That is, let's say alpha and beta are the roots, then alpha will be equal to or beta will be equal to 1 by alpha. The same thing we have taken, we have applied the formula of product of the roots, okay, and we have got that the coefficient of x square is equal to a constant and a equal to c is the required condition. Next is Suppose we are given the two zeros of a polynomial. Now how will we form the equation with it? Now remember, the general form of any equation where the two zeros is given is x square plus alpha plus beta x, minus alpha plus beta x plus alpha beta equal to 0. Now here we know both the roots, that is both the zeros we know, so we can add and then multiply, and whatever value we get, we can write that an equation. Now please notice that I have written a k. It is not necessary, but writing the k will just mean that any kind of coefficient which will be multiplied to this equation will also have the same 0. Okay, the last topic of this chapter, that is the division algorithm. We have done in previous chapter also, that is an Euclid's theorem. So please go and look at the other video for understanding that. There also we had the Euclid's algorithm. Basically, it is the same thing. So here also the concept basically still remains the same, that the polynomial will be there will be a polynomial, that is the dividend. Here instead of having a number, we will have the dividend in the form of a polynomial, we will have a quotient in the form of a polynomial, and we will have the divisor also in the form of polynomial, and the remainder as well, it will also be in the form of polynomial. Now one thing to know is, we know that the divisor or the remainder is always less than, is either ranges from 0, and it is always less than divisor. Now in this case, since we are taking a polynomial, there must be a condition like that. Well, luckily there is. The degree of Rx should be less than degree of Gx. The remainder, that the degree of remainder must be less than the degree of your divisor. As you can see that the degree here was 2. We can continue the division unless and until the degree of the remainder becomes less than 2. Once it becomes like that, the end product will be our remainder, and whatever will be in the top or in the side will be our quotient. Okay. So here I have taken an example. It has come in 2012 and 2017. I am dividing x square minus 4x plus 3, and this is the equation or the dividend. The question is asked as what should be added or subtracted, what must be subtracted to make this a polynomial that is exactly divisible by this. Okay. Now we always look at the first term and the term with the highest power. Now a good tip is always arrange the polynomials from highest to lowest, both for your divisor as well as for your dividend. Please remember this. Always arrange them from highest to lowest. If some power or some degree is missing in between, put a 0 and that respective x power. In that way, you will find it easier to solve the sum. And for the divisor also, if the divisor is not given in a proper manner, that is, it is not arranged with higher to lower, then also you should arrange them properly. Now, there is no need to add 0 into x to the power n if sometimes or if something is missing in this case. Okay. So, let us start to multiply. X square x to the power 4. Now, how much should be multiplied to x square to get x to the power 4? X square. So, that is why we have put x square. Now, once we have decided that we will multiply this whole equation with x square, we will do it and the respective plus minus sign will be adjusted and we will move to the next step. Now, in the next step, it is cubic form, right? So, the power or the degree of the x is still greater than this, so we can continue. So, here it is x square and the first term here is plus 6x cube. Now, with x square, how much should be multiplied to get 6x cube? 6x with the sign. So, that is why we have put here 6x. The first term of both the divisor and dividend is the deciding factor of what should be the quotient. Once you have decided that, multiply the same quotient with the whole equation and get this equation. Okay. Again the same thing continues, and lastly we get 2x minus 3. Now since the degree of this remainder is now smaller than the degree of divisor, we will stop here. So since this is the remainder, this has to be subtracted to get the whole divisor. Exactly divisible. Let's take another example. This is another example we have taken here. Now here we are dividing this with a polynomial gx, that means gx is the divisor. The remainder given is 3x plus 10 and 16x minus 43. Sorry, the quotient is 3x plus 10 and the remainder is 16x minus 43. Now, we know that the division algorithm says that Px, that is the polynomial which will act as the dividend, is equal to Qx into Gx plus Rx, where Qx is the quotient, Gx is the divisor and this is the remainder. So putting the same thing in this equation, we put accordingly what is the divisor, what is the dividend and what is the remainder. And after solving or simplifying, we get that Gx is x squared minus 2x plus 3. Well, with this, we complete our chapter. See you in our next video with a new topic. Thank you. If you like this video, please like, share and subscribe, and visit to our website www.newtongate.in, or you can also call us on the following numbers provided in the screen. Thank you and hope to see you in the next video.